Okay, lesson 62 is graphing solutions to inequalities on a number line. What's our objective, class? Get ready?
Graphing solutions to inequalities on a number line.
Very good. We're going to talk about less than, greater than, less than or equal to, and greater than or equal to. We're going to talk about the solid and hollow dots. And solid dots. We're also going to talk, sometimes we call them open and closed. We're also going to talk about how to solve inequalities, solving for x, and then how to graph the solution on a number line. So let's say Tom's thinking of a number between 1 and 10, and it's not just integer numbers, but he could be thinking of like 1.6 or 4.5. Of what possible numbers could he be thinking? Well, there was a couple, 1.1, 9.9, 3. So how would we solve that and graph that? We could express it as a single inequality. X, the number, is between 1 and 10. It couldn't be 1 and it couldn't be 10. So that's why we use less than, and x is less than. So x is greater than 1 and x is less than 10. How would we graph that? We would graph it by showing it couldn't be 1, but it could be really close to 1, like 1.000001. And so I like to think of this as like a shield. It protects it from hitting 1, but it can get really close. And it's somewhere this way, all the way up to 10, but it can't be 10, so I put a protective shield around 10, saying it can't be 10, but it can be right up close to 10, like 9.99999999999. So that's how we show that on a number line. All right, so let's graph this on a number line. A number greater than 2 and less than or equal to 4. So if it's greater than 2, I'm going to use a hollow circle. Greater. Show me with your arms which way, if I was shading greater than 2, am I going to shade this way or this way? Show me with your arms. Point. Some of you are not sure, but most of you are correct. I mean, this way. These are the numbers that are greater than 2. Ask yourself, is 3 greater than 2? Oh yeah, we're talking about which way are we going to shade. We're going to shade this way. I'm going to wait till it's quiet. Okay, thank you. 3 is greater than 2. We want to shade in this direction. But then we keep reading, it says less than or equal to 4. Well, that means it can be 4 because it says or equal to. So we put a solid dot. What kind of dot when it's equal? Get ready?
Solid dot.
Solid dot, good. Sometimes they call it closed. But it has to be less than 4, or less than or equal to 4, and greater than 2. So that's how I would show that. Here's some wrong ways to show that. That's wrong because it's not on the number line. Okay. There's some other wrong ways to do it. That's wrong. It's missing a few things. Number 1, it's missing labels, it's missing arrows, it's missing a tick mark between, and it's missing shading. So to fix that, I would do that. Now it's correct. Okay? I just have to make it be really clear where my shading is, and I have to have tick marks and have it labeled. So let's try this one. Christine is thinking of a number, and it's not just integers, but it could be a decimal or fraction. It says she doubles the number and the product is greater than 4. So let's take her number n. Let's double it. Double. And now that product is greater than 4. So we're going to write that in math language, greater than 4. So what is the solution? What numbers could she be thinking of? We could try 0. Is 0 times 2 greater than 4?
No.
Is that about 1/2? Is 1/2 times 2 greater than 4?
No.
And I could guess and check all these numbers, but there's a way to solve it using a balanced equation. I can eliminate the 2 by doing an inverse operation. I get n is greater than 2. So her number has to be something bigger than 2. If I chose 2, I'd get 2 times 2, which is 4. 4 is not bigger than 4. 4 is 4. So that's why it has to be a number bigger than 2, like 2.1 or 3 or 4. How do I graph that? I do a number line. I just need a few tick marks to show. And I circle 2 with a hollow circle. What kind of circle? Get ready?
Hollow.
Hollow. Sometimes it's called open. And then I pick numbers greater than 2. Well, greater is on this side. So I shade it in really dark. and then I make an arrow saying it's obviously this way. Okay. Let's try this one. Suppose I've got an equation with 2 steps involved. If I told you there was an equal sign there, you'd be like, oh yeah, we did that a couple weeks ago. We're going to treat it the same way we would treat an equation with an equal sign. We're going to use inverse operations to isolate x. So I work farthest from my x, and I start eliminating some of the numbers over there. So what do I do first? Avery. Minus the 1, very good. Minus the 1, those cancel. Tell me what to write. Okay, 6. And there's more, right? Is my answer 6? Greater than. This is kind of a new thing for us. It used to be like we would do an equal sign. We're going to treat it like an equal sign. We're going to copy it down just as it says. And we're going to line up our x's, line up the sign. And now we're going to solve again for x. We need to get rid of the 3. Use inverse operations, so we divide. That leaves us with x is greater than 2. How do we graph that? It's greater than, so is it hollow or solid? Think. Get ready?
Hollow.
Hollow. You guys were listening. Thank you. Hollow on 2. And then we say it out loud in our minds. We think, okay, a number that's greater than 2. Well, a number greater than 2 would be 3. So I know I'm going to be shading on this side. And I make it really dark with a big arrow. So it's really easy for Mrs. Boone to see what direction your shading is. Okay? A wrong way to do it would be like, okay, this marker is retired. A wrong way to do it would be to do this. That's my answer, Mrs. Boone. Can't really tell, right? You can't really tell, and I need a little bit more information. You know, at least a few. And then you could go like this. Just make it fat. Now you can tell. Now you can tell any number bigger than 2 would work. So I could put in a 3 right there, and let's see if it's true. It's 3 times 3, that'd be 9, plus 1, that's 10. 10 is greater than 7, so I know that works. I know I shaded on the correct side. Joseph.
Can you just write any number bigger than 2?
You mean in English words? Oh no, you have to draw it. You have to show this solution and box it, and you have to show a graph. Good question. I understand your question. So you have to do a solution and a graph. All right. What happens if Vincent goes into a store, $20? He went in to buy a notebook that costs $4. Then he notices that there's some packages of papers that are on sale for $2 a piece. He goes, oh, okay. How many packs of paper could I buy and still fall under my budget of $20? So let's do a math inequality or equation. $4 for his notebook, and now he's got $2 for each pack of paper. $2 per pack. 1 pack would cost him 2 packs would cost him 4, 3 packs would cost him 6. Okay, stay with me. Stay with me. All right, his budget's $20. Can he spend more than $20? Can he spend exactly $20? He has 20, and we're not worried about tax. Can he spend less than 20?
No.
It's totally okay. So let's say that in math language, he can spend less than or equal to $20. I just wrote an inequality. We are now going to solve for P. What P would make this inequality true? Jasmine.
Okay, can I just go step by step?
Yeah.
Okay, well, so you would have to subtract 4 from both sides to keep it equal and balanced and stuff. And
Okay.
that would, and that over there, that would equal to 16.
Okay.
And then you're gonna wanna divide 16 by 2, well, both sides, sorry, 2 by 2, but 16 by 2.
Okay.
So that you can keep it balanced still. And that will leave you with P is equal to, or, sorry, is less than or equal to 8.
Excellent. And this represents 8 packages of paper. So if he could buy 8 packs, could he buy 7.5 packs?
No.
No, the store wouldn't sell them half a pack. So in this particular case, we would go like this. Maybe we go 8, 9, 10, 7, 6, 5, 4, 3, 2, 1. I just thought I should use the number line down below. That's all right. Okay. He's got to use less than 8 packages, or exactly 8, so I could do a point there. 7 packs would be okay. 6 packs would be okay. 5, 4, 3, 2, 1, 0, okay? He's -1, okay? You can't buy negative packs of paper. So my solution really would just be from 0 up to 8. Technically, if I was being more advanced, I would say 0 and 8 are my lower and upper restraints on this inequality. P has to be between 0 and 8. Monica.
Couldn't you just sell the packs of paper?
That's how we can get negative. Okay, your turn. You've got a inequality right here. Write this down on your paper. I want you to isolate x. Isolate x. So give me a solution, and then graph it. Okay, again, write this down and solve for x. Put your pencil up when you've got it. Okay, Spencer, what did you come up with? What was your solution?
So what I did is I subtracted 2 from the 2 there.
Did you minus 2?
No, add 2.
Add 2. Okay, good. Just checking. All right.
And then you're with you have okay. So then you're gonna 3 plus 2 equals 5, which means 5 is that symbol to x, and then
Less than or equal to x. Okay, good. Okay, let's say that out loud. Remember, 5 is less than or equal to x. But don't I usually, when I am solving these, don't I usually say x is greater than or x is less than? Don't I usually start with x? Can I say this in reverse? X is greater than or equal to 5. Either they're both correct. They both say the same thing. But if I want to start with the x and the big side's pointing to the x, if I rewrite it the other way, I have to write the big side pointing to the x. So that x is greater than or equal to 5. So that changes my thinking on my graph because I saw a lot of people graphing it the wrong direction. Here's 5. Solid or hollow?
I'm going to go solid.
Solid.
And then you're going to have a big thick arrow pointing.
Okay, I'm writing down another name for talking.
Counting down 4, 3, 2, 1.
This way?
Yes.
Check it. Say that one more time. Say that out loud.
X is greater than, so then you're going to go right.
Yes, I'm going to go right because 6 would be greater than 5. 7 is greater than 5. So then this would be my solution. Big, thick line with a big, thick arrow. And then it would be obviously then going to the right. Okay, any questions on this? That was kind of to throw you off because it was reversed. I was going to move this up to make sure. Okay, we're on page 425. Take a stand-up break.